Hello everyone. So today we'll be discussing on the module 3 concept. That is, there are two theorems in this. It is moment area method and conjugate mean method. So we'll deal with the first theorem and the first method, that is called as moment area method. So in this moment area method, there are basically two theorems. The two theorems are, the first theorem is Mohr's slope theorem, and the second theorem is called Mohr's deflection theorem. So Mohr's slope theorem determines the change in the slope. It determines the value of theta b. Thus, if you want to find the change in the slope, you have to just find out the area of M over EI diagram for the given bending moment. And the second theorem deals with Mohr's deflection theorem, and it determines the vertical displacement of the member. So you can see here, this is a beam which is unloaded. So when you load the beam gets deflected in this shape. So now we have to find how much is the rotation at this end and how much is the deflection happening. You can see here, deflection is maximum at the center. You can see this line. This line is the neutral axis. So deflection is maximum at the center and rotation is maximum at the ends. So this is what we are supposed to find out using these two methods, that is moment area method and conjugate mean method. So we'll deal with the first method, that is moment area method. Now using this method, we'll find out how much is the rotation and deflection taking place. Now as we have discussed earlier, that this is a cantilever beam with a point load at free end. Now AB is a cantilever beam wherein A is fixed, B is free, and there is a point load B at B, that is point load W at B. Now the first thing is, if you want to find rotation and deflection, we'll first draw the deflected shape of the beam. So this is the original beam and this is the deflected shape of the beam. Now in this deflected shape of the beam, you can see here, this is the original beam length. Now the deflected shape looks like this. So again, how to analyze and how to draw this is by the simple method. Wherever there is load acting, that portion bends, and as it is a free end, if you apply the load at the free end, there exists maximum slope, maximum deflection. Okay, according to the boundary condition, we know that, see here, end A is fixed. So that means there is no chance of rotation and no deflection taking place at end A. That's why the deflected shape of the beam, when you try to draw it, it goes straight, and after that it bends here. So first you have to draw the deflected shape of the beam. After this, we have to mark the bending moment diagram. So this is the bending moment diagram. So the prerequisite for knowing or drawing this M or EI diagram is you should know the bending moment diagram for all the possible cases. That is for cantilever or simply support or overhang. May it be any type of beam, you should know the bending moment. So in this case, it is a cantilever beam. Free end, always the bending moment at the free end is always 0 and it is maximum at the fixed end. So now at B, I'll show the bending moment 0, ordinate. This ordinate is 0. Next, we have to show bending moment at A. So it is nothing but force or load into its perpendicular distance. So load into its perpendicular distance will give me the maximum ordinate here. Now, why I'm drawing it below the 0 line is because if you check to the right side of A, it becomes RHS. So this portion is RHS. So according to sign conventions, to the right side, RHS side, always the clockwise moment is negative. That's how I've shown this here, negative. And maximum ordinate will be at A, that is force, W into L. So I've shown it below the 0 line. And then this is 0 ordinate, this is maximum ordinate. You have to just draw a linear line. Now our main interest is to draw the M over EI diagram. So if you want to draw the M over EI diagram, it is the same bending moment diagram, but only the ordinates will have to divide it over EI. So at B it is 0 and at A it is maximum. So it is W into L is maximum ordinate. You have to divide this ordinate over EI. So that's how it is WL over EI. And we'll be finding the moment from the free end. So when you're finding the moment from the free end, that is at B. So we'll be finding the centroid of this. So we want to find centroid of this. So area of a triangle. So this is the area of the triangle. The centroid of the triangle is close to the base. If you want to find centroid, it is close to the base and far from the apex. So base is a line, apex is a point. So if you want to find the moment, it is nothing but you have to find from the free end always for cantilevers. So from the free end, so free end, this is the apex. So because it is the apex, if you know the centroid of the triangle from the apex is 2/3 of L, that is 2/3 of this length. Okay, after drawing all these diagrams, now directly we can use the two theorems to find out the slope as well as deflection. Now if you want to find theta b, so theta b you have to find. So we'll always mark this theta b with respect to theta a. Likewise, delta b with respect to delta a. Now, theta b to a, if you want to find how much is this deflection. So we know that we have already put the boundary conditions here that theta a is 0 and delta a is also 0 because it's a fixed support. There is absolutely no rotation and no deflection happening here. So that's why theta b is equal to, here if you're finding this, theta ba. So theta ba is nothing but theta b minus theta a is equal to, we'll use the first theorem, that is area of M over the EI diagram between P and A. So this is B and A. You have to find M over, this is M over EI diagram. So you have to find the area of this. Now area of this is, so it is a triangle. So area of a triangle is half into base L and height WL over EI. So when you solve this, you'll get WL square over EI. Now, theta B is what you're supposed to find, and theta A, we know that using the boundary conditions, it is 0. So now that's how theta A is equated to 0 and theta B is equal to WL square over 2EI. So we have found out this value. So theta B is nothing but it is the maximum value, and that's how it is WL square over 2EI at the free end. Likewise, we'll use the Mohr's second theorem to find the deflection at B. Now, if you find deflection at B, so again same thing. Delta B A is equal to delta B minus delta A. That is nothing but delta B is nothing but it is the maximum deflection. So maximum deflection is at B and deflection at A is 0. So now delta B A is equal to, you use this method. So basically see here, this is one method to find out using integration and this is the second method. So we'll use the second method because it is easy to find out all the values. So now if I find delta B, it is nothing but it is the moment of area of M over EI diagram between B and A about B. So again, we have to find this about B because B is the free end. So if you want to find moment of area, here, how do you find moment of force? It is force into distance. Likewise, moment of area is nothing but area into its CG distance. So that's how we have found out here. This is the area into its CG distance gives us moment of area. So moment of area of M or EI diagram between B and A about B. So delta BA is equal to, as usual, first find the area. This value gives us area into its CG distance. So area is half into base into height into CG distances we have already found out because we are finding out from B, so it is 2/3 of L. So it is now half into base into height into 2/3 of L. So this is CG distance. So area into its CG distance will give us moment of area. So when you solve this, you'll get WL cube divided by 3I. And this is the maximum deflection. This is how we solve both the quantities, that is theta B and delta B. Likewise, if you check out the next problem, okay, let's check the next problem. So here, determine the rotation and deflection at the free end. That means at B. So you can see here at A it's a fixed end, at B it is a free end. So there is a UDL here up to complete length L. So now, as usual, after this, draw the deflected shape of the beam. So again, deflected shape of the beam, the fixed end. At the fixed end, there is absolutely no rotation and no deflection happening. And when you draw this, so again, when you draw this line here, exactly at B, draw a tangent. Just pull this curve extra and draw the tangent like this, straight. And then mark this. So you'll get, this is theta b, and the vertical distance between the original position of the beam and the deflection portion of the beam gives you delta b. So after this, draw the deflected shape of the beam. After drawing the deflected shape of the beam, then you have to draw the bending moment diagram or M over EI diagram. So you can see here, again, to the right side there is a load. To the right side of A there is a load. So again, RHS, the anti-clockwise is positive, anti-clockwise is positive, clockwise is negative. That's how I've shown this in the negative side. So now A to B I've shown a zero line. Then at B, because it's a free end, so moment at the free end is zero. And then if you want to find this force into perpendicular distance, so this is W into L. W into L is the load into half of the CG. So W into L is the load into half of the length. So it is L by 2. It is W into L by 2. So that's how it is WL square over 2 EI. So again, why I've put EI? Because this is the M over EI diagram. They've shown M over EI diagram. Now, because it's a UDL, we'll draw a parabolic curve here. The curve should be parabolic. That's a UDL. So now, once you find out, this gives us the area. Now, after knowing the area, from B, you should know the CG distance. Now, if you have a parabolic curve, the CG distance is 3/4 of L. CG distance is 3/4 of L. Now, how to know this is, I've given you a quick table. Okay, you can just check out in this table. So first thing is a parabola, or it's a semicircle. So in the semicircle, if you want to find the area of the semicircle, it is 2/3 of x into y, and the centroid of the semicircle. Now check this out. Centroid is always measured from the right end. It means from this end. So if you want to find the centroid, it is always half of the x in the first case. Next case is, this is a quarter circle. So in the quarter circle, again, area of a quarter circle, 2/3, 2/3, like this. 2/3 of x into y. That is the area. And again, if you want to find the centroid from the right end, centroid from the right end is 5 by 8 times x. So if you measure like this, it is 5 by 8. Then similarly, if you want to find a cubic parabola, so this is a cubic parabola. So cubic parabola area is 1/3 of x into y. So you can see here, this curve is inward like this. So that's why it is 1/3. If it is outward like this, then it is 2/3. So now area is 1/3 of x into y. So again, if you measure from the right end, it is 3/4 of x. And similarly, if you want to find the trapezoid, this is trapezoidal. So area of this is h by 2. This is height by 2 into a plus b. Will give the area. Similarly, if you want to find y bar, if you want to find like this, y bar. So it is h by 3, 2 times a plus b divided by a plus b. Okay. So taking a quick note of this list. So we'll come back to the problem. So it is ours is a it was a cubic curve. So you can see it is a cubic curve. So cubic curve and centroid is from the right end, it is 3/4 of L. So now if we apply the formula, so the first formula says the Mohr's first theorem, that is, if you want to find slope, by using the area of M over EI diagram. So if you want to find theta B, theta B is nothing but theta B minus theta A is equal to, it is area of M over EI diagram. Area of M over EI diagram. So see, you can just write theta B minus theta A, and directly you can just write this area of M over EI diagram between B and A. So if you check this out, so area of M over EI diagram. So again, it is a cubic curve. So because it is a cubic curve, it is 1/3 of L into WL square by 2EI. So when you solve this, you'll get WL cube by 2A. Again, here theta B is unknown, theta A comes to 0 because it's a fixed support. So we directly will get the value of theta B, that is WL cube by 6EI, and theta max is WL cube because theta B is maximum, and that's how theta is maximum here, WL cube by 6 here. Similarly, apply Mohr's second theorem and find the deflection. So again, if you want to find deflection, it is M over, it's a moment area into its CG distance. It is moment of area of M over EI diagram between the given 2 points and about the free end. Now see here, this is the area. If you want to find delta B, this is the area which we have already found out here, WL cube by 6 here. Directly you can apply this value here into its CG distance. So CG from the right end, you are measuring the CG from the right end, which is 3/4 of L. That's how it is. I've written here 3/4 of L. It is WL raised to 4 divided by 8 here, and this is the maximum deflection. That is WL raised to 4 divided by 8 here. Okay. Now, similarly, now check this out. Determine slope and deflection of loaded beam by moment area method and take EI constant. Now in this problem, you can check there are two loads here. This is a UDL which is spread only on 4 meter, and there is a 100 Newton load, 100 kilonewton load at the free end, that is at C. Okay, when you have such type of problem, there will be two deflections and two rotations, because this UDL causes rotation and deflection about B. Then this extra load causes extra deflection and load, extra deflection and extra rotation at the given point. So when you try to draw the deflected shape of the beam, see here again as usual, this is a fixed support. Draw the original shape of the beam. So this is a dotted line. After that, you can just check up to certain length it runs straight, and after that the deflected portion of the beam is like this. Here at B it rotates and deflects less comparatively to C point, because C is the free end, and at free end always deflection and rotation is maximum. And so you can see here, this is delta B, this is delta C, vertical displacement. If I draw a tangent here, this is theta B, draw a tangent theta C. Okay, so now what we'll find out here is they asked us to find only beam end, determine slope and deflection for the loaded beam end by moment area method. So beam end is C. So you're supposed to find out only theta C, delta C. These are the two things you're supposed to find out. Now what we'll do, because there are two different loads, we'll draw the bending moment diagram separately. One is due to point load and the other is due to UDL. Now see here, due to point load. Okay. Now first thing is bending moment due to point load. Bending moment due to point load, that is 100 kilonewton. So we have the bending moment as first thing due to point load into its perpendicular distance. So don't consider this load. When you're finding out only this, imagine there is only 100 kilonewton acting. So it is 100 into its perpendicular distance, 7. So that's how AC, here A to C At C it is 0 and 100 Newton force, 100 kilonewton force into its perpendicular distance. So that is 100 into 7, that is 700 kilonewton. 700 kilonewton is the bending moment, kilonewton meter. So again, because it is acting to the right side, so right side forces, the clockwise forces are, or the clockwise force or clockwise moment is negative. That's why I've shown it on the negative side. So this is 700 kilonewton. And because it's a point load, I've shown this as a linear line. Next, at B, there is a UDL which is acting only up to B. So that's how here up to B, from B I'll draw this load intensity. So again, as usual, at B it is 0 because that is the first point where it is starting, and then it is maximum at this point. So load into perpendicular distance divided by 2. So it is now, I'll start here. At B it is 0. See here at C there is no load acting only because load starts at B and ends at A. So we'll start from this point now. This is because of the UDL. So at B it is 0 and at A it is maximum. So we want to find out, this is 10 load into perpendicular distance into distance divided by 2. That is, this is nothing but the CG of the distance. So that's how it is, 10 into 4 into 2. So it's 80 kilonewton meter. And now you can see, because it's a UDL, I've shown this as a parabolic curve. Okay. Alright, after drawing this, now as usual, here 700 divided by EI will give us M over EI diagram. 80 divided by EI will give us M over EI diagram. So now we'll apply first theorem. We'll apply Mohr's first theorem, or it's also called as first moment area theorem. So if you apply this, so theta B minus theta A, theta B minus theta A, but what is our interest is we have to find theta C. So to find this theta C, I'll write it as theta C minus theta A is equal to, first theta C minus theta A. Theta A is already 0. So theta C is equal to area of M over EI diagram due to point load and area of M over EI diagram due to UDL. So now this is a triangle. So theta C is area of a triangle plus area of a parabola. First thing, area of a triangle. Area of triangle. Now because it is M over EI diagram, in the beginning only I'll take 1 over EI outside. So that simplification gets simpler. So area of a triangle. Area of a triangle, half into base. There is 7 into height, 700. So half into 7 into 700 plus next quantity, area of a parabola. Now see here, again it's a parabola, cubic parabola. So we've already known this. So the area of this is one third of base. So base is only 4 meter. So one third of 4 into 80. So when you add this, you'll get, so total, if you add this area of a triangle and area of a parabola, you'll get theta C. That is, you'll get this quantity divided by EI. Now, always theta will be measured in terms of radians. Deflection will be measured in terms of meter or mm. Okay. Now see here, this is a positive answer. You got the answer positive. So because it's a positive answer, so it is clockwise. In case if it's negative, then it is anti-clockwise. Okay. So this is the first thing you found out. Next is theta C. You found out the rotation. Likewise, you have to find deflection. If you want to find deflection, apply second moment of area, or it is called as second theorem, that is deflection theorem. And you can see here, if you want to find delta C, it is nothing but it is the first moment of M over EI diagram about C. Now it is nothing but moment of M over EI diagram. See here, this is M over EI diagrams. It is nothing but bending moment diagrams. You find the CG or find the moment of these two diagrams, you will get delta C. Now see here, the meaning of moment of M over EI diagram is area area into its CG distance. Area into its CG distance. Now, always you'll find the CG about the free end here. Because this is what you're supposed to find out. That is, you have to find theta C and delta C. So what I'll do here is 1 over EI. Now it is nothing but area into CG distance. Area, so this is the area of a triangle into CG distance. Area of a parabola into CG distance. That's it. So now you see here, 1 over EI, I'll take it common because it is the M over EI diagram, it is common for all. So 1 over EI, I'll take it out. And next area is half into base into height. Half into base into height. So we have already found out this. So again, no need to find out this. So we have already found out here. We have already found out here. So it is area. So it is area into its CG distance. And this is again area into its CG distance. We have already found out the area here. So you can directly apply this value here. Instead of calculating again here, you can directly take this value because this is the area of the triangle. So this is area into CG distance. Now you can see here we are measuring with respect to C. So with respect to C, from C it is again centroid of a triangle measured from the apex of the triangle is 2/3. So that's why it is 2/3 of 7 meter. And similarly, this is again area of a parabola is here, that is 106, and then CG of this. Okay, now if you see CG of only the parabola is 3/4 of 4. So it is 3/4 of this distance, 3/4 of 4 meter. But we are finding the CG with respect to C. So you have to add +3 here. So this is the CG of the parabola only. But we are finding with respect to C. So that's why you have to add +3 meter distance here. So 3/4 of 4 plus 3 meter will give you the CG with respect to C. So that's how when you solve this, take 1 over EI common, solve this, you'll get delta C as this value. Now again, answer is positive. Because the positive answer, the deflection is downward. So deflection will be either upward or downward, and rotation will be either clockwise or anti-clockwise.